Good day guys! To have an emphasis about the higher order derivative, we prepared a short definition and explanation on what is a higher order derivative. So, higher order derivative is the nth derivative of the function f, where n is a positive integer that is greater than 1, is the derivative of the quantity n minus 1. We denote the nth derivative of function f by f of n. It simply means, guys, that in a higher order derivative, we are not only considering the first derivative, but also the second derivative, the third derivative, and so on, until to the nth derivative. For example, in order for us to get the second derivative of a given function, we need to derive the function twice until we get the second derivation of a given function. So, to understand further about the topic, we prepared 4 examples for you to understand more about higher order derivative. So let's start.
Good day everyone, this is GEIA CABUDLAN from group number 1 and I will be solving the first problem, which is to find the fourth derivative. Our first example is c of x is equal to negative 32x raised to the power 5 plus 3x cubed plus 26x squared minus 10. So we have our given here and we have to find the fourth derivative. So in finding the derivative, we have to use the theorem number 6, which is the derivative of sum and difference of a function. So the first derivative is of c of x is equal to negative 32 times the quantity of 5x raised to the power of 5 minus 1 plus 3 raised to the power times the quantity of 3x raised to the power of 3 minus 1 plus 26 times the quantity of 2 times raised to the power of 2 minus 1 minus 0. So next step will be to multiply this. So we have first the first derivative of c of x, this to this, to this, to this. So we will get negative 160 x 5 minus 1 is so 4, so negative 160 x raised to the power of 4 plus next is 3 times 3 is equal to 9. Copy the x, then 3 minus 1 is 2, so we have 9x squared plus 26 times 2 is equals to 52. Copy the x. So next is the second derivative. So the second derivative of c of x is equal to negative 160 times the quantity of 4x 4 minus 1 plus 9 times the quantity of 2x raised to the power of 2 minus 1 plus 52 times the quantity of x 1 minus 1. So the same on the first derivative, we have to multiply this to this, to this, to this. So the answer will be the second derivative of c of x is equal to negative 160 times 4 will be equal to negative 640. Copy the x, 4 minus 1 is equal to 3, so we have negative 640 x cubed plus 9 times 2 is equal to 18. Copy the x, 2 minus 1 is 1, so we didn't have to copy it, plus 52 times 1 is equal to 52. Copy the x, 52x. So we are now in our third derivation. So we have the third derivative of c of x is equal to negative 640 times the quantity of 3x times raised to the power of 3 minus 1 plus 18 times the quantity of x raised to the power of 1 minus 1 plus 0. So the same to the previous derivation, we have to multiply. So we have the third derivation of c of x is equal to negative 640 times 3 will be negative 1920. Then copy the x, then 3 minus 1 is equal to 2, so negative 120 times x squared plus 18 times 1, so 18, copy the x. So here we go. So now we are on our fourth derivation, which is our goal for this problem. So the fourth derivation of c of x is equal to negative 1920 times the quantity of 2x raised to the power of 2 minus 1 plus 0. So, like in the previous derivation, we have to multiply. So we have the fourth derivation of c of x. I'm sorry. The fourth derivation of c of x is equal to negative 1,920 times 2 is equal to negative 3,840. Copy the x. So this is our final answer.
Good day everyone. I am Kenneth B. LOYGOS from 11 STEM A Providence. I will explain the number 2 and number 4 example. So for the number 2 example, we need to find the general formula for the nth derivative of g, where g of x is equal to the quantity of 6x squared minus 12 times the quantity of 3x squared minus 6x. So in order for us to get the general formula of the given function, we need to derive the function until the derivation of g of x would be equal to 0. So in order to derivative this, we need to apply that theorem number 7. So we will have g prime of x is equal to the quantity of 6x squared minus 12 times the derivative of 3x squared minus 6x plus the quantity of 3x squared minus 6x times the derivative of 6x squared minus 12. We're gonna simplify this function. So we will have g prime of x is equal to the quantity of 6x squared minus 12. Since we know that the derivative of 3x squared minus 6x is just equal to 6x minus 6 plus the quantity of 3x squared minus 6x. And since we know that the derivative of 6x squared is just equal to 12x, then we will have 12x. We're gonna simplify this function. Then we will have g prime of x 36x cubed minus 36x squared minus 72x plus 72 plus 36x cubed minus 72x squared. Then after that, so therefore we have the first derivative of function g prime of x is equal to 72x cubed minus 108x squared minus 72x plus 72. Then since it is not equal to 0, so we need to derive it more for us to be equal to 0. So we will have g prime of x. By applying the theorem number 6, we will have 72 times the quantity of 3x raised to the power of 3 minus 1 minus 108 times the quantity of 2x raised to the power of 2 minus 1 minus 72 times the quantity of x raised to the power of 1 minus 1 plus 0. Then after that, simplify this function. Then we will have g prime of x is equals to 72 times 3 is equals to 216. Then x squared, because 3 minus 1 is equals to 2, so we will have 216x squared. And then multiply negative 108 to 2, then we will have negative 216. Then 2 minus 1 is just equal to 1, so we will have x. And since x raised to the power of 1 minus 1 is just equal to 1, then we will have negative 72. So therefore, the second derivative of function g of x is equal to 216x squared minus 216x minus 72. We need to get the third derivative of the function. So by applying the theorem number 6 again, then we will have 216 times the quantity of 2x raised to the power of 2 minus 1 minus 216x times the quantity of x raised to the power of 1 minus 1 is equal to 0. So simplify this, then we will have g prime of x. Multiply 216 to 2, we will have 432x, and multiply negative 216 to x, then we will have 216. So therefore, the third derivative of g of x is just equal to 432x minus 216. And since it is not equal to 0, we need to get the fourth derivative of the function. So we will have g to the power 4 of x. So by applying again the theorem number 6, we will have 432 times the quantity of x raised to the power of 1 minus 1 is just equal to 0. Then simplify it. Therefore, the fourth derivative of the given function is just equal to 432. To get the fifth derivative of the function, so we will have g raised to the power of 5 of x is equals to 0. So since it equal to 0, na-equal na siya sa 0, therefore we now have the general formula for the nth derivative of g. Therefore, the answer of this is g raised to the power of n of x is equal to 0 where n is greater than or equal to 5.
So, hi guys, I'm CARLO GERALDEZ and I'm here to show you how to find the third derivative. So, hi guys, I'm here to show you how to find the third derivative. So first, we are given the derivative of the function of y is equal to 4e raised to the power of 2x plus 8. Then, to make it simple to solve, we need to find the first derivative, which is y is equal to 4, then quantity, then inside the quantity is the e raised to the power 2x plus 8, then multiply it by the derivative, then the derivative is multiplied to this given the 2x plus 8 bracket. Then next is we need to multiply the derivative to 2x plus 8, then it will become copy y is equal to 4, same, only copy, it will become 2. So next we need to multiply these 2, then it will become y 1 is equal to 4 2e raised to the power of 2x plus 8. Then we need to multiply the 4 to 2, then it will the answer of the first derivative. So 4 times 2 is equals to 8, so y prime is equal to 8, copy the e raised to the power of 2x plus 8. So it is our first derivative. Then we proceed to the second derivative, so come y is equal to, same as the first, we need to put the 8, then bracket, copy the e raised to the power of 2x plus 8, multiply to the derivative, then the derivative multiply to 2x plus 8, then bracket. Then next, same as the first, we need to times this, so it will become is equal to 8, copy 2x plus 8, it will become 2 since the derivative of the x is 1 and the 8 is 0. Then we need to times these 2, so it will become 8 quantity of 2 e raised to the power of 2x plus 8. Then we need to multiply the 8 to 2, then it will become y second derivative is equal to 16 e raised to the power of 2x plus 8. So that is our second derivative. We will now in the third derivative. So y 1 2 3 is equal to, same as 16, the quantity, the inside of quantity is the e raised to the power of 2x plus 8, then multiply by a derivative, then the derivative multiplied to 2x plus 8 plus 8, then it will become 16 quantity of e raised to the power of 2x plus 8 multiplied to the 2, sorry for that, then the multiply the 2, then it will become 16 2 e raised to the power of 2x plus 8. Then we, same as the first and second derivative, we need to multiply the 16 and 2, so that it will become is equal to 32 e raised to the power of 2x plus 8. So this is our third derivative this is our last answer, the third derivative.
For the last example, which is we are going to find the second derivative of the function y is equals to k of x is equal to 9x squared plus 12x minus 27 all over 4x. So first we're going to find the first derivative of the given function. So we're going to apply the theorem number 8. So we will have k prime of x equals to 4x times the derivative of 9x squared plus 12x minus 27 is equals to 18x plus 12 minus the quantity of 9x squared plus 12x minus 27 times the derivative of 4x, and the derivative of 4x is just equal to 4 all over 4x squared. Let's simplify this. So we will have k prime of x multiply 4x by 18x plus 12, we will have 72x squared plus 48x. Then multiply 4 by 9x squared plus 12x minus 27, we will have 36x squared plus 48x minus 180. And simplify 4x to the power of 2 is just equal to 16x squared. Then simplify again, we'll have k prime of x equals to 72x squared plus 48x. Multiply negative sign to negative 36 is equal to negative 36 x squared. Then multiply negative sign to positive 48x, we will have negative 48x. And multiply negative sign to negative 108, we will have positive 108 all over 16x squared. Then simplify this, so k prime 36x squared. Then copy 108 plus 108 all over, copy this 16x squared, then we will have 16x squared. So therefore, after that, we're going to simplify this. So therefore, we will have k prime of x is equal to 9x squared plus 27 all over 4x squared. Therefore, the first derivative of this function is just equal to 9x squared plus 27 all over 4x squared. We're going to find the second derivative. So we're not done yet. So we will have y prime is equal to, since k of x is just equal to 9x squared plus 27 over 4x squared, alas ibutang 9x squared plus 27 over 4x squared. Then we're gonna go into find the derivative of this. So 4x squared times the derivative of 9x squared plus 27 is just equal to 18x minus the quantity of 9x squared plus 27 times the derivative of 4x squared. So we will have 8x all over 4x squared raised to the power of 2. Then simplify this, we will have multiply 14x squared to 18x, therefore we will have 72x cubed minus multiply 9x squared plus 27 to 8x, we will have 72x cubed plus 216 all over 4x squared raised to the power of 2 is just equal to 16 raised to the power of 4. So simplify again, we will have 72x cubed minus 72x cubed minus 216 all over 16x4. So we will have negative 216 all over 16x raised to the power of 4. And we're gonna reduce it, therefore the second derivative of the function of this function is just equal to y prime 9x squared plus 27 4x squared is just equal to negative 27 2x cubed. Thank you.